Hello, RailSort is a program that illustrates sorting networks. You can perturb and put one of these tiny cows and you get to see that this network sorts them. So you can place, for example, this one in rail 0. And you see that the network still sorts. Actually, you can run a simulator that will tell you the cost of the network, how many parallel time steps it takes, and how well does it do. Or you can go one permutation at a time, checking, or you can choose to put in a random permutation as input. These bridges can be removed or changed. So if you click on it, you can choose downgoing rail. Obviously now it does not sort properly. Similarly, if you delete it, and of course now it does not sort, even if you put a new permutation. There's some things or some patterns you can study. For example, if we remove this one here and remove this one here, this pattern in which the bigger cow goes up guarantees this ladder here that you find the smallest of all of them, no matter where the smallest is. For example, if I put the smallest here, it still shows up there. If I put the smallest here, it still shows up here. And if I put the smallest here, it still shows up here. No matter what permutation you put in, the smaller elements goes here. And the reason is because no matter what these two gates, after this, the smallest of the first two will be in this position. And then here, the smallest of the two will be here. And then here, the smallest of the two will be. So no matter how many rails you have, and actually we can add a rail here. As you can see, this could be even bigger. Right. The smallest, let's put the smallest somewhere in the middle, all right, it's a selection sort. Once you find it, it will drop all the way down. Again, if I put it here, it will drop all the way down. It turns out that you can see here that the cost of finding the smallest is linear in the number of gates and linear number of time. So the pattern we were doing before, let's change it. If I make another ladder here in parallel, the two smallest ones would be here. Now, out of the 4 remaining rails, the smallest would be caught by the ladder. And that's why you see the pattern of sorting that we had before. So if we repeat the pattern again, all right, we get the 3 smallest there. And as you can see in the screen, I now need quadratic number of operations for selection sort, if you want to think it that way. So this will sort now no matter what permutation, because each ladder has found the smallest in the remaining rails after we have found the smallest on this rail.